Hi, my name is Justin Ocampo, and this is my second lab for computer organization and architecture. So turning decimal to binary first. So this problem will be converting the decimal number 25 to binary. First off, we will divide by 2 and record the remainders. So it will be start off with 25 divided by 2, which will equal 12 remainder 1. Then we go to 12 divided by 2, which equals 6 remainder 0. Then we go 6 divided by 2, which equals 3 remainder 0. Then we go 3 divided by 2, which equals 1 remainder 1. And then lastly, 1 divided by 2, which equals 0 remainder 1. And then we go all the way from the bottom to the top. So our answer would be 25 to the base of 10, which equals 11001 to the base of 2. Binary to decimal. So the problem is converting binary number 1101 to decimal. So first off, we will multiply each digit by the powers of 2. So 1 times 2 to the power of 3 plus 1 times 2 to the power of 2 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 0, which then equals to 8 plus 4 plus 0 plus 1, which equals 13. So the answer would be 1101 to the base of 2, which equals 13 to the base of 10. So decimal to octal. The problem is converting decimal number 83 to octal. So first off, we'll divide by 8. So 83 divided by 8, which equals 10 remainder 3. 10 divided by 8, which equals 1 remainder 2. And then 1 divided by 8 equals 0 remainder 1. So here we will read bottom to top like we did before. So it would be 1, 2, 3. So the answer would be 83 to the base of 10, which equals 123 to the base of 8. Octal to decimal. Problem is converting octal number 47 to decimal. So first off, we will multiply by the powers of 8. So 4 times 8 to the power of 1 plus 7 times 8 to the power of 0, which then equals 32 plus 7, which equals 39. So our answer will be 47 with a base of 10, which equals 39 to the base of 10. 47 to the base of 8, which equals 39 to the base of 10. My bad. Decimal to hexadecimal. So we will convert decimal number 172 to a hexadecimal. So we will first off divide by 16. So 172 divided by 16, which equals 10 remainder 12. Then we go 10 divided by 16, which equals 0 remainder 10. So then we will convert the remainder. So 10 equals A, 12 equals C. So we will read from the bottom to the top as before. So AC. So the answer would be 172 to the base of 10, which equals AC to the base of 16. Oh no, okay. My fault. So binary to octal. So problem is converting binary number 101101 to octal. So first we will start grouping in threes from the right. So the number would be adding a 0 to the beginning. So the three groups would be 001, 011, 101. So 001 equals 1, 011 equals 3, and 101 equals 5. So the answer would be 135 to the base of 8. So we will read top to bottom, from front to back, or first to last, however you want to say it. So octal to binary. So problem is converting octal number 675 to binary. So first we will convert each digit to a 3-bit binary. So 6 equals 110, 7 equals 111, 5 equals 101. So combining all those numbers will be 110111101. Hopefully I read that right. And then the answer would be 675 to the base of 8, which equals 110111101 to the base of 2. Hexadecimal to octal. So the problem will be converting hexadecimal number 3A7 to octal. So step 1 will be converting the hexadecimal to binary. So 3 will equals 0011, 8 equals 1010, 7 equals 0111. So the whole number would be 011, 0011, 1010, 0111. Second step would be grouping into threes for octal. So the three groups would so 4 groups of threes would be 001, 110, 100, 111. So now the last step would be converting to octal. So 001 equals 1, 110 equals 6, 100 equals 4, and 111 equals 7. So the answer would be for 387 to the base of 16 would be equals 1647 to the base of 8. So we read from top to bottom, or first to last, or front to back, however you want to say it. Octal to hexadecimal. So the problem will be converting octal number 345 to hexadecimal. So step 1, convert octal to binary. So 3 equals 011, 4 equals 100, 5 equals 101, which then equals 0111, 00101. So second step would be grouping into 4s for hexadecimal. So it would be 0001, 1100, and lastly 0101. So converting to hex, 0001 equals 1, 1100 equals C, and then 0101 equals 5. So the answer would be 345 to the base of 8 equals 1C5 to the base of 16. Hexadecimal to binary. So the problem is converting hexadecimal number B3F to binary. So B equals 1011, 3 equals 0011, F equals 1111. So combining all those numbers together would be 101100111111. Hopefully I read that right. So the answer would be B3F to the base of 16 equals 101100111111 to the base of 2. That's a lot of ones. Binary to hexadecimal. Convert binary number 11011010101 to hexadecimal. So the first step would be grouping into 4s. So it would be 1101, 1010, and lastly 1101. Second step is to convert them. So 1101 equals D, 1010 equals A, and then 1101 equals D again. So the answer would be DAD to the base of 16. Decimal to binary. So converting the decimal number 25 to binary using the subtraction method. So it will be the largest powers of 2. So 25 minus 16, which equals 9. Remainder 1. So 9 minus 8 equals 1. 1 minus 4 equals, well, nothing. It's a 0. It's 0. So 1 minus 2, nothing. And then 1 minus 1 equals 0. So, well, 0 remainder 1. So, the answer to 25 to the base of 10 equals 11001, base of 2. So we read from top to bottom here in this list. Decimal to octal. So convert the decimal number 83 to octal using the subtraction method. So largest powers of 8. So 83 minus 64 equals 19. Remainder 1. 19 minus 16 equals 3. Remainder 2. Oh wait. I think I read this wrong. So equals 3. So 2 times. So 3 minus 8, nothing. And then 3 minus 1 equals 0. So the answer would be 123 to the base of 8. Decimal to hexadecimal. Convert the decimal number 172 to hexadecimal using the subtraction method. So largest powers is 16. 172 minus 160 equals 12. So 12 equals C. Well, 12 became A. So, and then 12 equals C, the remainder. So 172 to the base of 10 equals AC to the base of 16. Binary to decimal. Convert the binary number 101101 to decimal using the subtraction method. So powers of 2. So 101101 equals 32 plus 0 plus 8 plus 4 plus 0 plus 1, which ultimately ends up equaling 45. So subtraction method also gives the same result. So the answer would be 45 to the base of 10. Lastly, hexadecimal to decimal. Convert the hexadecimal number 2b to decimal using the subtraction method. So 2b equals 2 times 16 plus 11. So 2 times 16, 32, plus 11 equals 43. So 2b to the base of 16 equals 43 to the base of 10. And that is it. So thank you.